Good morning, and thank you very much for the opportunity to be here at ETH today. In fact, I spent 13 years at ETH in the past, first in the physics department, where I earned my PhD in 2016, and later in the computer science department, where I worked on various components of Scion as a postdoc in Adrian Perrick's group. This year, I joined the R&D team of Mysten labs to apply some of these technologies in the real world. And I'm now very excited to be here today to present some of the opportunities and synergies between Scion and the blockchain technology developed at Mysten Labs. Mysten Labs is a young but already very successful startup with its headquarters in California and around 150 employees distributed all over the world. It was founded 2 years ago by former members of Facebook's blockchain team and is the main developer of the Sui blockchain, which was launched publicly in May of this year. Since then, it has already achieved major milestones, for example, the largest number of transactions ever recorded on a single day by any blockchain. And Mysten Labs is now working on further improving its distributed consensus infrastructure, as well as exploring completely new ways of using the technology. And one big element of these efforts is Scion, where Mysten Labs has made substantial investments and is committed to bring the technology to its production deployments. So the first question I want to explore today is, how does our blockchain benefit from Scion? And really, one of the main points is that the decentralized nature of blockchains brings its own challenges concerning networking. A blockchain is typically operated by multiple globally distributed nodes to prevent any single entity or even individual countries from gaining control or interfering with the operation. These blockchain nodes are responsible for validating and executing transactions, and typically a threshold of these nodes needs to be operational and reachable at all times. So fundamentally, for their communication, they rely on a reliable global networking infrastructure. A crucial point here is that centralized solutions to the availability problem in the internet cannot be used by the blockchain. For example, other traditional IT systems use systems like Cloudflare or large private networks to gain availability and security properties for their global communication. But this is not feasible for blockchains. Not just because of the cost that was mentioned earlier, but especially because this centralization contradicts the promise of a blockchain that there is no single point of failure. If the blockchain nodes relied on a private network for communication, then the network operator itself would be able to single-handedly disrupt the blockchain operation. So what we would really need is a public, redundant, and decentralized network that provides availability guarantees, and this brings us to Scion. A bit more concretely, we have two main types of communication that we need to defend against denial-of-service attacks. The first is the internal communication between blockchain nodes. The second is the communication between the users of the blockchain and the infrastructure. In the first case, we want to ensure that even a very dedicated attacker cannot disrupt the communication and thus the operation of the blockchain nodes. In the second case, we want to ensure that every user of the blockchain can at any point reach the infrastructure and thus execute transactions without delay. Now, of course, like any critical IT system, there are a multitude of mechanisms that are used to defend the system. So all exchanged messages are cryptographically authenticated, and there are multiple layers of filtering and rate limiting that are used to defend against denial-of-service attacks. Yet the situation, like for other IT systems, is still less than optimal. Ideally, many attacks would just be fundamentally impossible, and the network layer itself would provide us with availability guarantees. So for both types of communication, we're now looking at Scion systems that allow authenticating packets and filtering out attack traffic as early as possible to achieve availability guarantees for legitimate traffic. Now, for the second part of my presentation, I want to look at blockchains and Scion from a different angle and explore how the Scion ecosystem can in turn benefit from blockchains. A very obvious benefit for the Scion ecosystem is that as a globally distributed system, a blockchain using Scion would present a strong push towards globalization of the network. But I want to talk about a different and I think particularly exciting possibility, namely to use a blockchain itself to support Scion. And to understand what is possible there, I first want to emphasize that today's modern blockchains are really very, very different from the early cryptocurrencies that were developed. One big aspect here is that modern blockchains are really far greener than early cryptocurrencies like Bitcoin. This is mainly due to the fact that many current blockchains use the efficient proof-of-stake mechanism to reach consensus, in contrast to proof-of-work, which reduces energy consumption and emission by many orders of magnitude. So where a single Bitcoin transaction is associated with the same carbon emissions as flying from Zurich to Lisbon, a Sui transaction is rather comparable to a traditional financial transaction in that respect. Sustainability is one area, but there have been major developments in what a blockchain can actually do. Where Bitcoin only supports limited programmability through the Bitcoin script, modern blockchains, including Sui, allow developers to write smart contracts in Turing-complete programming languages. Another aspect that determines what use cases can be supported is the speed of a blockchain, or in networking terminology, its latency and throughput. For Bitcoin, the block schedule limits both metrics, and Bitcoin has a latency on the order of tens of minutes or even a few hours and can only process 5 to 10 transactions per second. In contrast, Sui reaches finality for most transactions within less than half a second and can process thousands of transactions per second, which puts it on par with traditional systems like Visa, for example. And finally, a similar factor of 1,000 can be seen in the costs. In Bitcoin, a single transaction costs a few dollars. In Sui, a single transaction costs less than 0.1 cents. Now, all of these developments put together now enable completely new applications that can be built on these decentralized infrastructures. And this brings me back to Scion, which is in a unique position to benefit from these new opportunities because of its clean separation of control and data plane. What I mean is that Scion packet headers typically contain all the information that routers need to make forwarding decisions. And routers do not really care or know how the source obtained this information, as long as this information is authentic. Now, this enables the possibility to perform some network control plane tasks in an external system like a blockchain. And really, blockchains are perfectly suited to play this role because their decentralized nature perfectly matches with the distributed Scion network that explicitly does not rely on single roots of trust. So what can a blockchain-based system do now? Well, a blockchain provides all mechanisms to represent network resources as digital assets, and these digital assets can then be composed, transferred, and coordinated among multiple parties through the use of smart contracts. Particularly useful is the feature that multiple operations can be made atomic, such that they either all succeed or all fail, which substantially simplifies certain processes. Of course, if we now build control plane mechanisms on a blockchain, we require very fast and cheap transactions. But as I mentioned before, these are conveniently provided by, for example, the Sui blockchain. And an additional point is that financial settlement can be directly integrated into these smart contracts, such that network operators have a financial incentive to participate in these systems. As a concrete example, my colleagues and I have developed a system similar to Colibri, where now the Sui blockchain plays the role of the control plane and distributes bandwidth reservations to end hosts. I'm now coming to the end of my presentation and just want to say a few words about our current efforts and next steps. We're currently working on 3 different topics simultaneously. First, we're interacting with ISPs, IXPs, and cloud providers to further extend the Scion network and make it possible to obtain a Scion connection anywhere on the planet. The second effort concerns integrating Scion into Sui. So we currently have an internal test network of Sui nodes that communicate exclusively via Scion. After integrating additional mechanisms, we plan to bring this to our production deployments in the coming years. And finally, we're further exploring new control plane mechanisms that benefit from this coordination of digital assets via the blockchain, and design the smart contracts and digital assets for those. I now want to leave you with our long-term vision of a future internet built on a secure and truly decentralized foundation, and thank you very much for your attention.